Okay, here are the notes. Take these down. It's going to seem kind of pretty simple at first because I do want to start with something that you know, but then it's going to build up to the problems here that we're doing in pre-calculus. Okay, here it is. This is for when you have the division, right? When you're doing function operations. So we'll start with, well, this is the way you'll see it in delta math, where it says f of g f divided by g of x. Well, we know that that's, and instead of using the divided sign, we're going to want to put f of x divided by over g of x, right? Okay, so you did one assignment like this on simple ones, but you didn't do the ones where you have to actually include the factoring. Okay, so we're going to review that. Okay, so number one, 20 divided by 5. Well, you're going to say it's 4, right? 20 divided by 5 is 4, but I'm going to say, okay, show me the work. How? Prove it. Okay, so when you have division, right, because this is division, 20 divided by 5, how can I prove that it's 4? How can I show work on this? Is by showing that there's factors here. 20 has factors, and then one of these factors is actually gonna cancel with the 5, right? 20 is actually what? Well, 20 is 5 times 4, right? Well, 20 is also 2 times 10, okay? But I'm using 5 times 4 because I know that there's a 5 down here, right? This is 20 is 5 times 4, and 5, well, 5 is just, 5 times 1, but we're just going to leave it as 5. And then see, these divide out. Like when you have 5 over 5, right? 3 over 3, 5 over 5, 10 over 10 is 1, right? But we say they divide out. I know people say they cancel out, but it's really 1 over 1. It's really 1 over 1, so keep that in mind. And this is how it happens that, see, you get the answer 4. Okay, and then very similarly, number 2, what if you have, let's say something like 9 over 36. Well, 9 over 36 is not 4. I know some of you are thinking like, well, yeah, 9 times 4 is 36. That is incorrect. See, some of you see this and you see this and you think it's saying the same thing. It's not. How do you know if it's 4, which is 4 over 1, or 1 over 4? Well, again, 36. Can 36 be written as factors? Can 36 be written as factors? Think of it this way, right? Which is a product of two numbers. The factors are the product of two numbers. Can 36 be written as a product of factors such that one of them is 9? See, this one's giving you a hint. This one's already telling you what's one of them going to be. So if one of them has to be, if this one's 9 here, well, guess what? One of them, I hope, is going to be 9 down here, because if it is, it's gonna work, right? So sure enough, yeah, 9 times what? 9 times 4 is 36. And yeah, I could have picked 18 times 2. 18 times 2 is 36. 12 times 3 is 36, right? But why did I go with 9 times 4? Because I'm telling you, this number's a hint for you. If this is a 9, can I get this with a 9 times something? Okay, sure enough, yes. The answer is yes. But see, some of you still here, you'll still drop the ball. The answer is not 4. I know that the number that's left over is 4, but it's in the denominator. Remember I told you when these divide out, this is like, it's 9, it's just like 1 over 1. See, the 1 is in the numerator. This answer is 1 over 4. Not like over here. Over here, yeah, we would have been left with 4 over 1. 4 over 1 is 4. This one's 1 over 4. Okay, but how is this gonna work for polynomials? Well, polynomials, let's say for example, I'll do one that's already factored. I'll do this. What if I have x minus 3 times x plus 2 over, right? These are two factors, just like two numbers, but now they're expressions. X minus 3 times x plus 2. and then times x minus 3, and then x minus 8. You see, if I can get one of these expressions to match here when it's in multiplication, just like here when it's multiplication, if I get them to match, and one of them in the numerator and the denominator match, they divide out. See, this is going to divide out. X minus 3, x minus 3, they divide out. It's like 1 over 1. And that's what's going to happen to these problems. One of them will match, and that's going to be your hint. Okay, so obviously here the answer is this part that's left over, right? The x plus 2 over x minus 8. You see, you can't reduce these. You can't say, oh, now reduce the 2 and the 8. No, these have to stick together. You can't just simplify in pieces. You can't just say, oh, or you can't say, oh, cancel out the x's. You can't do that. It has to stay together. The only thing that can touch an x plus 2 is if it's another x plus 2. Other than that, you don't cancel the x's, or you don't reduce the 2 and the 8. Okay, that's another thing. All right. So now let's look at some of these problems, right? Like number 4 here. And what if you have something like x plus 6 over, and then you're going to have something like x squared plus 8x plus 12. Right? So, well, the ones that you're going to see in the beginning, I'm telling you.
Good morning,
hold on.
Happy Friday. Teachers, if you have...
Okay, sorry about that. Okay, so what's happening here? I'm telling you, one of these, hopefully like the easy ones, that's going to be one of the factors. See, this is your hint. This one here is your hint. And it's telling you what the way this one's going to factor out, right? This trinomial here is a product of two factors, right? It's factorable. You're going to have to factor it. And you're like, how do I factor this? Well, I'm telling you, the way these problems work out is one of these has to match up here. And it's telling you, it's giving you a hint, right? So if this one's x plus 6, one of them is x plus 6. Right? Because they're eventually going to divide out. Eventually they're going to divide out. That's how these problems are going to work. So if this is x plus 6, now your question is, well, I look at the x, and I look at the first term, and I look at the first term. X times what is x squared? Well, x times x to give me x squared. Now I look at the last term, that's a plus 12. That's a plus 6. What 6 times what gives you 12? Well, that's a positive 12. It has to be a positive 2. And yeah, you can sit here and check and distribute this out or multiply these two, and you'll see how the middle term is 8. Okay, it is 8. But focus on securing the front 2 to give you the x squared. Focus on securing the back 2 to give you the 12. And I'll tell you real quick how you check the middle. You just multiply the inside 2 and you multiply the outside 2. That is a 6x, and the outside 2, it'll be a 2x, and see the 6 plus 2 is your 8 right there. So it works. So bottom line is now we got what? Well, let me clean up this problem. I got sloppy, right? So now the top was, or the numerator was x plus 6. The bottom now is this. The bottom now is now x plus 6 times x plus 2. And now what happens? See, this x plus 6 divides out with that x plus 6. The answer is what? Not just x plus 2, it's what? 1 over, right? This is a 1. If there's nothing in the numerator, you put a 1. You don't put a 0. 1 over x plus 2. Okay, number 5. Let's do another one. 5. How about if I have x squared minus 4x minus 21. X squared minus 4x minus 21 over. And let's go with x minus 7, right? So again, remember, this one's already, that's already in its simplest form. I know how these problems work out. One of the factors for this top one is going to cancel with the x minus 7, so that tells me that, well, I only have x minus 7 here in the bottom. That means that one of these up here, when this one factors out, one of them has to be what? One of them's going to match this x minus 7. Yeah? This one has to be factored when you factor it out, but I'm telling you, this is giving you a hint, right? This is going to be factored out. And if this is x minus 7, the question is, what do you need here to give you the 21? Well, for the front, x times x, right? X times x to give you the x squared, okay. And how about for the negative 21? Well, I'm not going to put negative 3, because negative times negative would be positive. So that, I don't want a positive, I want a negative 21. This one has to be a plus 3. Okay, so check your signs. And then these divide out, right? This one, you do get x plus 3 over 1. The answer here is just x plus 3. And the way they're going to write it on for here for the, function notation is they'll put something like, last one here, number 6, they'll put, okay, f of x is equal to x squared, what do I want to do? Plus 4x minus 32. And then they're going to put, g of x is equal to, what should I put here? X plus 8. See, the problem's just going to be set up like this, right? They're going to put it like this. They're going to put this function, they're going to use functions, and then they're going to say, okay, find what? Find, and again, on delta math, it'll say, parentheses f divided by g of x. Remember that? Okay, so then you're like, okay, well, what does this mean? Oh, well, that means the function of f of x over divided by g of x. And then you're like, okay, fine. What does that mean? Well, that's when now you have what? F of x, which is what? This x squared plus 4x minus 32. And then g of x is what? X plus 8. But see, it doesn't just stop there. Now, this is where you got to factor it and simplify this down. It's not finished right there. Okay, and how do we finish that? Well, is this factorable? Let's see. Well, if this is an x plus 8, then one of the factors here is going to be x plus 8. And your job is to find what the other one is, right? This is going to match with this. Your job is to find what this is. So it's kind of like doing half of the work for you. It's giving you one of the factors. Your job is to find the other one. This would have to be what? X. X times x to give me the front. 8 times what gives you a negative 32? Negative 4. All right, so this replaces this one. And now you got this over this. And then obviously you know what happens, those divide out. Your answer is x minus 4 over 1. Well, that's just x minus 4. All right, there it is.